So let us see projectile motion. First of all, we'll study when a particle is thrown from the ground, right? So such kind of a case, there is a ball and we have thrown this ball with some speed u, and this speed makes an angle theta with the horizon, and it will follow a parabolic path. Why? Because it is under a uniform acceleration, right? Why uniform acceleration? In this case, we are ignoring the effect of air. There is no air. You can consider it as a vacuum, and there is only one acceleration, which is in the downward direction.
Okay.
So it will be your uniform accelerated motion, right? Now, in this case, we have acceleration only in the vertically downward direction. So we will split our problem into one-dimensional problem, right? So let us take this axis, this as our x-axis, and this as our y-axis, right? Okay. So what we're going to write, we will write all your initial velocity and the acceleration along x and y direction. So your ax will be 0, right? Acceleration in the x direction is 0. And acceleration in the y direction will be minus g, right? Why minus? Because we have taken upward direction as positive. That is positive y, right? And your initial velocity in the x direction will be what? It will be u cos theta, right? Can you see that? If I resolve u in two mutually perpendicular direction, it will be u cos theta in the x direction and u sin theta in the y direction. Is it clear? Now, so along x-axis, the motion is uniform motion, right? It has a uniform motion. It will cover equal distance and equal interval of time along the x-axis. Along y-axis, it has uniform accelerated motion. Is it clear? Say this position is A and the highest position is B and this position is C. Now the acceleration is in the vertical direction. So if I show you the component of velocities in the horizontal and vertical direction at an arbitrary point, so this component will be u cos theta. And let us say this is V, right? At the same level on this side of the parabola, this component will be u cos theta. And this will be V, right? Got it? So at the same level, the vertical component, if the vertical component is some, say 10 meter per second at this particular point, then it will be 10 meter per second in the downward direction at the other point. Is it clear? Okay. So now, and what is the velocity at C? So velocity at C will be what? So this will be your u cos theta and downward will be your u sin theta. Is it clear? So some important parameters will be the time of flight from A to C. From A to C will be the time of flight. The time spent by the ball in the air before hitting the ground will be time of flight. And then we will calculate what is the maximum height attained by the ball from the ground. And then we'll calculate what is the range. Range is defined as the displacement along the x-axis. So the line AC, the line segment AC will be your range, right? Okay, how far you can throw a ball. So usually we measure a distance on the ground, right? Suppose you're testing a missile and you will measure the distance on the ground, on the earth, right? Okay, it travels from this point to this point, right?
Yes.
Okay. So now the range, and then the fourth thing that we will calculate will be the equation of trajectory, right? Equation of trajectory. So first of all, let us derive time of flight. So for that, we will consider vertical direction. In y-axis, you can see that the particle goes from A and reaches C. The displacement in the y direction is 0, right? From A to C, your displacement in the y direction is 0. Clear? And your initial velocity is u sin theta. Okay. And let us say the time taken from A to C is t. So we can apply Sy equals to uyt plus half ay t square. Is it clear? So Sy is 0, uy is u sin theta into t plus half ay is minus g, right? Into t square. So time of flight will be 2u sine theta by g. Got it? Or you can remember it like this. It will be 2uy upon acceleration in the y direction. Got it? Okay, so second we will calculate the range. Let us calculate the range, right? Now range, for that we will use x-axis from A to C, right? It's a uniform motion. So your range will be what? It will be ux into time of flight. Clear? Distance is speed into time.
Yes.
So ux is u cos theta. Time of flight is 2u sine theta by g, right? Clear?
Yes.
Or you can write this as 2 ux uy by g, or you can write it as u square sine 2 theta by g. Got it? So u square sine 2 theta by g. So you have to remember all these formulas, right? U square sine 2 theta by g. Time of flight is 2u sine theta by g. Now, what is the maximum value of range? Range depends upon theta, right? So for given u, right, r will be maximum when your sine 2 theta is equals to 1, right? Because the maximum value of sine function is 1. We want to maximize the range. So you can clearly see that when sine 2 theta is equals to 1, your theta will be pi by 4. Is it clear? So your range will be maximum at theta equals to pi by 4, and your r max comes out to be u square by g. Got it? Okay, so now we have range. So this is our maximum range. So it will happen when the angle is 45. So if you must have seen, like in case of a javelin throw, the thrower always throw it at some angle, say, and that angle has to be 45 degree.
Oh.
Right? So if you want to maximize the range, in that case, you have to throw it at an angle of 45. Next is the maximum height. So the maximum height will be this. The distance of point B from the ground, right? So this is your h max. At the highest point, the velocity in the y direction will be 0. It will have only horizontal velocity, which is u cos theta. Is it clear? Now for maximum height attained by the projectile, we will apply in the y direction, right? So you can take a velocity in the y direction will be 0 from A to B, right? We are applying from A to B, right? Equation of motion. So Vy will be 0. Uy will be u sine theta, right? Ay is your minus g. Is it clear? So let us apply the third equation, which is Vy square equals to uy square plus 2ay into s, right? Sy. Now this Vy is 0. Uy is your u sine theta square of that plus 2. Ay is minus g. Sy is your h max, right? So from this, your h max comes out to be u square sine square theta by 2g. Got it? So this is the formula, and the maximum value of h max happens when theta is 90 degree, right? So you can throw a ball to the maximum height when you throw it vertically, right? So the maximum value of this happens at theta equals to 90. H max is maximum at theta equals to pi by 2, and its maximum value will be u square by 2g, right? So now one more important concept. Suppose if your angle of projection, okay, so angle of projection are complementary angles. Suppose I throw a ball at theta and 90 degree minus theta. Say 30 degree and 60 degree, right? They are complementary angles. Okay. So what is the range in this case? When the range in the first case will be u square sine 2 theta by g, right? In the second case, the range will be u square sine 2 90 degree minus theta by g, right? Which will be u square sine 180 degree minus 2 theta, right? Sine 180 minus something will be sine theta, right? Got it? That is same as r1. Is it clear? For the same speed, if you throw a ball at two different angles which are complementary of each other, right? Which are complementary angles, then you will get the same range. For example, there is a ball, you have thrown it at an angle of 30 degree, right? Say it reaches somewhere here, and you throw the same ball with the same speed at an angle of 60 degree, right? It will again reach at this particular point. Okay, so 20 or 70 degree, your 40, say 40 and 50 degree, right? All these are complementary angle, you will get the same range. For complementary angles, range is same. Okay. Now let us see what is the equation of trajectory. Now you have to derive equation of trajectory will be in x and y only, right? Because it's a path. So you have to derive it. You have to like find an equation which is in x and y only. So let us consider, say this is our ball or particle that we have thrown. So say it reaches somewhere here at time t, right? Okay. Say, so its coordinates will be x comma y, right? Okay. So if you want to find x, so your x will be what? So if I apply, so this is u and this angle is theta. So in x-axis, so your x will be what? It will be u x into t, right? So it will be u cos theta into t. Clear? So for y displacement in the y direction, we can apply sy equals to uyt plus half ay t square. Is it clear? Sy will be your y, uy is your u sine theta into t plus half ay is your minus g into t square, right? Now
Yes.
we want to find an equation which does not contain t. So now you can substitute the value of t from the equation number 1 into the equation number 2, right? So from this, I can substitute here as t equals to x upon u cos theta. Okay. Right? So if I do that, I will get y equals to u sine theta into x upon u cos theta minus g upon 2, and we have x square upon u square cos square theta. Is it clear? Now this u will get cancelled out, and we have tan theta, x tan theta minus g x square upon 2 u square cos square theta. Is it clear? Now this is your equation of trajectory. Okay. So this is form one, right? If I take, say, x tan theta common, right, in this equation, say I have y equals to x tan theta minus g x square upon 2 u square cos square theta, right? If I take x tan theta common, I will get 1 minus g x square upon 2 u square cos square theta, and I have x tan theta in the denominator, right? So this cos theta will get cancelled out, and one x will get cancelled out, right? Now you can see, like, if I take this g into the denominator like this, so we have 2 u square cos theta sin theta by g, right? Okay, so you can write denominator as, so 2 u square cos theta sin theta by g, or you can write this as 2 u square sin 2 theta by g. Is it clear? What is this? Range, right? So you got another form of your equation of trajectory, which is x tan theta is equals to 1 minus x by r. Clear? Got it? So this is this form number 2.